So I need to review it.
Yep. No, it's always good to remind me, hey, don't forget to record.
Okay.
Because I start asking questions and getting into questions, and my brain goes math. So, and Jesse, that is both kind of a nice thing in some ways about this tool, and also, as I said, a very dangerous thing about this tool, because you don't have to be really super clear on all those kind of the big tools or all that factorial stuff we talked about yesterday. You can be kind of unsure about all that, but if you know what the tools do, you can make them work. But at the same time, it's dangerous because you can just kind of start ignoring, what the tools are doing, and just, if I just type the, what numbers do I type in to make it work? We want to make sure we're understanding what we're being asked and what we're being told. So, by the problem, by the calculator. So it does have that kind of, double-edged sword. It's nice to not have to do all that calculating. But at the same time, that separates us from what's actually happening and can make it harder to, remember what the tools do and remember, which tool to use when. The more abstract they become, the more dependent it is for us to make sure we know what's going on. And that's one of the reasons I spent yesterday talking about all of that stuff that we're really not going to do very often, because having that idea of what is this problem talking about, what is this process we're actually doing, why does this thing work, is so important. So that is a very, very good point, Jesse. It is very possible to have no idea what's going on here, but if you put the right numbers in the right place, it's going to work. But we have to understand what's going on enough to make sure the right numbers get in the right place. So what I want to do for a little while is take this question and kind of mess with it. What if it was asked slightly differently? What if it asked kind of a different question? How would we change our response? To kind of be working on, how do we adjust this tool to give different types of answers? So I still want to use the 3% deficit rate. So we're going to keep that P at 0.03, and we're going to keep the 10 randomly selected items. But I want to find, what is the probability that, we're going to change this question around. So what is the probability that, let's say, 4 have a defect? So we're still starting by identifying that this is a binomial problem. Right now that might seem, well, of course it's a binomial problem. We're in the binomial section. But again, that's going to be really important later. Identifying what type of problem we have. So this is a binomial problem because it has that yes, no, success, failure, 2 options for each trial. Second thing to determine, is this a PDF question or is this a CDF question? That's a shorthand for, is this a single value question or a cumulative question? So are we being asked for a range of values, or are we being asked for a particular value? Which one in this question?
Just one particular value.
Just one particular value. So we are a PDF, a non-cumulative question. So as soon as we have that, as soon as we have binomial, we should be able to pick out our N and our P. As soon as we know whether it's cumulative or single value, we have our x, in this case, x equals 4. If we want to draw that diagram, either 0 successes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All we're looking for in this case is that 4. So this is a kind of a much smaller question than the one before. The one before wanted this big range, and it wanted an upward range, so we had to subtract what was below it. This just wants the probability of 4. Okay, so on the calculator, binom PDF, and it's always NPX on the X on the calculator. So binom PDF 10.034. That's all we're asked for. Isabel?
This might be a dumb question, but I'm still having a hard time finding the binom PDF on my calculator.
Oh, not a dumb question at all. It's in a weird place. The button here that says vars, if you look right above that, it says dist for distribution. So second vars will bring up that distribution tool. And in that distribution tool, where is it? There it is. In that distribution tool, you'll find the binomial CDF and PDF.
Oh, okay. Thank you.
Okay, good. And this thing I brought up before, I don't know why it's not wanting to move. It's being weird. Had that in it. I'll try to bring that up before you can take a screenshot of that. But yeah, it's under that distribution tool. We will actually, in chapter 7, be using that same set of tools in there quite a bit. So knowing where those are is good. Is anybody using Excel instead right now? Okay, then I'll just focus on what the commands are for the calculator. We'll do Excel stuff on Thursday. So that binomial, that should give us a result. You guys, I'm seeing a couple different results. 0.0147. What's the point? 0.001. Is that what this one is?
Yeah.
Oh, I got you.
Yeah.
So 0.0001. 0.0001. Now, that's a very tiny percentage. Anytime we're using that PDF, we should expect a fairly small percentage, because it's asking us what is the probability of something very specific happening. Anytime it asks for something really specific, I expect it to be small. I didn't expect it to be that small, but that's okay. Anybody back that number up? Andrew, Jesse?
Yeah, that's what I got too.
I don't disbelieve it. It's just that it's really small. Isabella, you got that too?
No, I got the same number for like the initial one we did, like 0.036 or something like that. I don't know if I plugged it in wrong. It's very possible that I did.
Are you using cumulative distribution function or PDF? Are you using PDF or CDF?
PDF.
You're using PDF?
Mhm.
You guys are gonna make me do it, aren't you? Make me do stuff. oops, equals binomial disk. This is number of successes 4. The order is different on Excel. Number of trials 10. Probability of success 0.03.
Okay, I see. I got a different answer.
And cumulative no. So that's the Excel commands. And let's see what it gets. Yeah, now there is a 4.2 there. Now your calculator might say 1.42e. What would that be? 1, 2, 3, 4, -4. That's scientific notation for that. Remember scientific notation, that's 1.42 times 10 to the -4th. So it's saying, okay, take that decimal and move it 1, 2, 3, 4 spots. So that's the value it gave. So anytime you have that E is saying that's the exponent for scientific notation.
Okay.
So watch for that.
So basically on the calculator, you just needed to move the decimal point 4 places to the left, and then the answer would be correct.
Yep.
Because I was saying, wait a minute, I didn't get that, and I did it 3 times, and it came up with the same 1.46. So I understand now.
And that's something, because sometimes these probabilities are going to be really small, that's going to happen every once in a while. So it is something to be careful of. Okay, so since we're generally being asked for this for 4 decimal places, that's why you guys very properly said, okay, just the 0.0001. And that's, again, a very small probability, but anytime we're talking about single values, we tend to get small probabilities. Questions about that? Now, if there's only a 3% chance, well, let me ask that question later. Okay, let's modify this question again. Switch to a pink question. What if we have 4, 2, well, let me not do 4, 2. Let's go from probability that we have from 1 to 5 defects. Or actually, I don't want 1. It's going to be a small probability, but that's okay. From, let's say, 2 to 5 defects. So now we're starting to get a little bit more interesting. So first off, it's still a binomial question because our setup, we have yes or no, defect or not, so that didn't change, and it's not going to change. Is this a PDF or a CDF question? Is this a single value, or is this an interval of values? Well, now it's an interval of values, but unfortunately not a straightforward one. That's okay. We'll deal with that. But that does mean we're probably going to be using our CDF tools. This type of problem is really where the diagram comes into play really in a really handy way. We want to know what's between all these values between 2 and 5. So we want that range. Now, we could find that range by just finding the value at 2, finding the value at 3, 4, and 5, and add them up. And we could do that, it would work. Unfortunately, if it was like between 23 and 104, we'd have to add all those up, and I don't want to do that. So we need to have a way that we don't have to add up the individuals. So what do? Well, our cumulative tool, by its nature, does a particular value and down. So if we did CDF with 5, so CDF, I'm just going to say CDF with 5. So we use the CDF function with our X as 5. We would get everything from 5 down. That's too much. But maybe useful. If we did CDF with 2, we'd have everything from 2 down. That would be CDF if we used the X value of 2. Well, we don't want from 2 down. We want from between 2 and 5. But what can we do with those 2 values, those 2 boxes, the blue box and the green box, to make the orange box?
Then just -2 from the answer.
I would say subtract 2 from the answer.
Sorry.
That's okay. It's part of my job, unfortunately. But yeah, if we subtract those, we're going to get that orange block in between.
The answer is 0.
The answer is close to 0. Tiny, right?
Yeah.
So what was it for the CDF?
For the CDF,
Yeah.
if you did it with 5, it's 0.999999862.
E to the something?
No, I didn't get that. Did you?
Oh, no, should have. Sorry, shouldn't have. You're fine. 0.99 what?
999999862.
Wow. So, because that goes all the way down to 0, we expect to have, almost no failures. That's, a large percentage. It's a very high % chance we'll have less than 5. Totally believable. What about the 2? Get ready for more 9s, right? How many 9s?
Mine came up with 0, but I think I pressed the wrong button. That's why.
Anybody got the value for this EDF2? Should be a bunch of 9s and stuff.
I got 0.9972.
Okay, so 9972.
7, 2, yeah.
So then if you subtract those, you'll get 0.002, 0.003 if you round, probably. Depends on what's after that.
27.
0.0028.
28 if you round.
Okay, so this is making a little bit more sense.
So Camilla, when you said you were getting a 0, were you getting a 0 from the CDF with 2 or from the subtraction, or did you figure it out?
I subtracted a 2 from my answer. I didn't go back through and redo it. I was like, okay. Yeah.
So the probability
I
of
did
being
my
less
subtraction in the wrong spot.
fair. So finding the probability of less than 5 and subtracting the probability of 2 or less gave us the probability between 2 and 5. Fair?
Okay. So oh, oy vey, oy vey. Oh, I'm sorry, I'm not muted.
Well, I thought you might have had a question there. Questions about that? Does that seem reasonable?
I got 0.0027.
It would have depended on how much you rounded when.
Oh, okay.
Yeah, you'd be fine.
Good. It counts in my open math.
Oh yes, quite a bit.
Okay. Yeah.
So when we say the probability from 2 to 5, we're not including the 2 in that, right? That's why we subtracted from 2 down.
Right. And usually it'll say things like including or not including. So this would be 3. This would be 3 and 4 and 5. If we want to include the 2,
Okay.
how would it change?
Well, I included the 2.
Well, we'd have to subtract from 1 down, right?
Yeah.
That would probably even be a better interpretation of how that's written. So then
Yeah,
we
that's
would
what I was
just
kind of thinking,
subtract that.
from 2 to 5. But it'll just kind of depend on what the wording in the question is, you say?
Yeah. Because we do want that too. Or if we want that too. So from to, or yeah. I think with how that's worded, Andrew, I think you're right. I think going the 1 down would have been better. How's that going to change our answer? This 9972, how much does that change with the from 1 down?
So it looks like the CDF from 1 down is 0.9655.
9655.
So then we're left with 0.0345.
I got the same thing.
Cool. Now,
Matt, so that worded from 2 to 5 actually doesn't mean you start at 2.
it really depends. Between is always a tough word.
Okay.
Because if you say, we want, or it's got to be between 2 and 5,
Okay.
do you mean it has to be between 2 and 5, but you include the 2 and the 5? Or is between 2 and 5 just the 3 and the 4?
Oh, yes.
So usually, say that strongly, usually when we talk about ranges, we will talk about them as closed intervals, included.
Okay.
Sometimes it'll say not including, or sometimes it'll be more specific, but by default, let's include those endpoints. What I did was particularly weird because I included one of them but not the other for some random reason.
Okay.
And should have been more careful. So in general, particularly on binomial questions, include those endpoints.
Okay.
When we start talking about problems that are continuously distributed as opposed to discretely, and that's what the issue here is that, well, there's this gap between 1 and 2. Well, it's a discrete problem, so there's nothing between 1 and 2, right? When we get into continuous problems and there's stuff between 1 and 2, we have to handle it a little bit differently. But we'll talk about that in chapter 7. So for right now, we're including endpoints. Don't worry about it. And usually that will come from a careful reading of the problem. So let's look at another one of these, and let's actually change this percentage a bit, and we'll be real careful about what we're putting into that calculator. So let's change this defect rate to something that's happening a little bit more often. Let's say it's happening, let's say it's happening 15% of the time. That's a lot. But instead of 10 items, let's say we're grabbing 40 items at random. And we want to find the probability that, let's say, less than, 5 have a defect. So same type of question, change the numbers, change the specific ask in it. But we still have a machine that produces some defect. I upped the rate to 15%. And we grab 40 items off the production run at random. And we want to find the probability that less than 5 of them have a defect. So again, first, this is still a binomial question because we are given a yes or no and a number of trials. As a binomial question, we should be able to pick out our n. We should be able to pick out our p. And if we want our q, our q. Second thing to decide was whether this is a PDF question or a CDF question. Are we asking for single values or are we asking for an interval? And the third thing we did is we tried to draw a diagram for it to get a sense of which intervals or what values we want. So decide on those things, try to decide how you're going to ask the calculator, and we'll look at exactly what, making sure we're happy with exactly what's getting put into that calculator.
Every time I entered in my calculator, when I hit enter at the end, I'm getting, it's saying I have an error.
Now, what are you typing in exactly?
I was doing second and then vars and then going down to binomial CDF or PDF.
Mhm.
Like for our last one, I did the PD or the CDF. So I
Mhm.
hit second vars, went down to binomial CDF, clicked on it, and then I put in 5 and closed my parentheses.
That's
And
the
it
problem.
says, oh, okay. What do you do?
That 5 was a shorthand. Our binomial PDF or CDF wants the number of trials, the probability, and then the number of successes. So for
Oh.
all of those problems, we needed 10 and 0.03. The last number was the number that was changing depending on what we were asking. So when I wrote, the CDF 5, that's just kind of saying, hey, what's that last number that we want? Fair?
So the 5 was the last number that should have gone in there.
Right.
So it would 10.03, then 5.
Yep.
How do you enter it in with a comma?
The
Or do
comma's
you
right
close
above
your
the 7.
parentheses?
The comma's right
There it is.
here above
Okay.
the 7. Isn't it weird to have a comma on your calculator?
It is weird.
But yeah, it's right above the 7.
And why in these do we not use the cumulative, like the 0 or the 1, like we were with what we did last night?
Because the Excel has one command, binomial distribution. That 0 and 1 at the end changes it from either P to C.
Oh, I see.
The
Okay,
calculator has 2 separate commands. Pick the one you want.
that makes sense. Thank you.
Sure. So in this particular problem, our number of trials has changed to 40, our probability of success to 0.15, our probability of failure to 0.85. This is a range of values. We want everything less than 5, so this is a CDF problem. Now we might have to be careful about exactly which group we grab, and that's where the diagram helps. Now, I'm not going to put in 40 tick marks, but from 0, 5, 10, 15, 20, 25, 30. Even labeling them that much might be a little obsessive, but that's okay. Good diagrams will make a difference in your life, I promise. And we want less than 5, okay? What values are less than 5?
Four,
Four,
3,
yeah.
2, then 1,
4, 3, 2, 1, and
and 0.
0. Notice, kind of getting back to Andrew's point, does less than 5 include the 5? 5 is not less than 5. So we do want our binomial. It is a CDF because we are doing cumulative. It's a value and down, so it's what our cumulative is built to do, so that's good. Our N is 40, our probability of success 0.15. But what value do we want from?
4.
We want that 4 and down. And I'm getting different answers up there. So I'm going to wait for some confirmation there.
I got 0.2633.
That's some confirmation. 0.2633.
Yeah, me too. When I fixed it.
Yeah. That 4-5 issue causes problems.
Yeah.
And that gets back to what we were saying, Essie, we have to know what the tool is doing, because if we just say, hey, I got a 15, I got a 40, I got a 5, plug in those numbers, it's not going to quite be right. Isabel?
Using the CDF function, I still keep getting 0.
So you use the binomial CDF.
Yeah, it's telling me like an upper and lower. Is that like where I would not? That's why I keep getting confused, I think.
Oh, you've got one with the sub menu in it. Wait, you're getting an upper and lower for the binomial CDF?
Yeah.
I wish I could see that better.
Can you see that? Or no?
Huh. So let that let that lower be 0, and the upper be 4.
Okay.
And what was on the rest of it?
40 and 0.15.
40 and 0.15. Okay, what does that give you?
Let's see what that does, shall we? I still get 0.
Let me see that sub menu again.
Let me get to it.
No, that's not the right tool. What's that number? What's that word highlighted up on top?
Normal?
Normal CDF?
Yeah, we want binom.
Okay, sorry. Oh, there we go. Okay, that's a
Okay.
B. Okay. Okay, this should help a lot.
The tool that you're using is the tool that we'll use in Chapter 7. If that helps.
I guess I'm thinking it way far ahead.
You are. You're just ahead of the game. Okay. So make sure you get that 26.33%. If you don't, let me know. Okay. So let's, again, modify this question. Let's say it said probability that more than, let's say more than 7 have a defect. So take a minute, set up that same question and see what happens. See what you get. Are you drawing the diagram? We have to like the diagram. And it might be good to put a little more specificity where some of those boundaries are. I mean, that boundary's at 40. More than 7 means our bigger numbers, right? But where is this line?
Eight.
Good, it's at 8. Because we want 8 or 9 or 10 or 11 and so on. Right? To be more than. Okay. Now, if we did our straight CDF unmodified, our cumulative tool, like all of our cumulative tools will be from here on out, our cumulative tools all give us from a value downward. In this question, do we want from a value downward, or are we looking at from a value upward?
We're looking at a value going upward.
We want 8 and up. Our tool doesn't give us up. Our CDF tool gives us down. So what can we do to get up if all we have is a tool for down?
1 minus 7 and down.
1 minus the other stuff. And this is a common response. This is something that's going to happen a lot. Our tool gives us down. Well, what if we want up? Okay, find the down and subtract it off. So if we want that purple part, we know the whole thing has to add up to 1. So 1 minus that blue part. That blue part is still an interval. It's a and down interval. So it's still a CDF. But where does it start? Where's this boundary? I know Andrew said it, but does it make sense that we can't subtract that 8? We want to subtract the 7 and down. So 40.15, we've got to subtract that 7 and down. I think this is the worst one, by the way, because on the one before, we didn't use the 5, we used the 4. So we moved the number. Here, when we drew our diagram, we wanted that 8 and up, but we end up using the actual 7 from the problem. So there's often a lot of really, very reasonable questions about, well, why does this one want the 6 or the 7 or the 8 or the 4? Why is this one moving up or down? And it's all about that. What do you want to include? We need that 8 and up included, so we can't subtract the 8. We're subtracting away the 7. Here, that 5 had to be excluded, so we wanted to count the 4 and down, so we had to put in the 4, 3, 2, 1. But it's a small change in the language to change that. If that said more than or equal to 7, then that would change our situation. If it said at least 7, that changes our situation. At least 7 would include the 7, and we'd have to subtract the 6 and down. Yeah. So we have to be really careful with this language. You guys have a value for that? Is that the 1354? No, it's not.
I got 0.2441.
0.2441.
Me too.
So, do you think these take practice? They take practice. So make sure we get that practice in. But there are two types of questions that we haven't looked at yet that hopefully will resonate more having done all that. You know, we're talking about, you know, what's the probability that it will be in this range or that range or more than this or less than this? You know, like what's the probability that we're more than 5, less than 7? We could ask those all day. How about, though, how many defects do we or should we, I don't know why I capitalized that, do we expect? And I'm going to add out of the 40. Now, that expect should now be a key word for us. We talked a couple days ago about expected value, right? What did we associate with expected value?
Average.
Which one?
Mean.
Mean. So how many should we expect? And, you know, you imagine if you grabbed 40 at random, you know, every hour for, you know, a month, you grabbed 40 at random and tested them. On average, how many would you have? How many defects would you have? Well, because, again, as we talked about before, when we were talking about expected value, because we're talking about a population, we have the whole probability distribution. It is a mu. It is a parameter. And if we grab 40 of them and 15% are supposed to have a defect, how many would you expect to be defective? Or how would you find it?
(15% of 40).
Yeah. You've got 40 of them. 15% of them are supposed to be defective.
6.
It's just MP. And you said that's 6?
Yeah.
People often get the expected value for binomial distributions wrong because they want it to be more complicated than that. (15% of the 40). Okay, 15% of the 40. Now here's the fun part. We have a mean that tells us on average we expect to have 6 defects. But what's the spread of that number of defects? What would be unusual? What would be typical? What range do we expect 99.7% of our defects, you know, number of defects to be in? What am I asking for in all those questions about, what's that, Michelle?
Standard deviation.
Oh, your thing's off, yeah. Standard deviation. It would be nice for us to have a standard deviation to go along with this. So if somebody asked, okay, well, the average is 6, is it unusual to find 10? Well, I don't know. I don't have a standard deviation. The nice thing about standard deviation for binomial distributions is it's a very nice little formula. It's not that big standard deviation formula we had before. It still has a square root in it. There's still some bits and pieces, but it's a nice comparative little formula. We do have to use the Greek sigma because it is not an S, it is not a sample standard deviation, it is a population standard deviation. So it's the Greek S sigma. I know it looks like an O, but it's the Greek sigma. But the formula is really nice. It does have a square root, but it's just N times P times Q. Probability of success times the probability of failure times the number of elements. That thing's square root is going to give us a standard deviation. Now, why that works is a little bit more complicated of a discussion. We could talk about that sometime later if you wanted to. It's essentially, if you essentially build the other big nasty formula out of probabilities and it cancels down to this. It's actually quite nice, but takes a little bit of doing. So it really is just a version of that other big formula in probabilities.
It's 40 times 0.15 times 1 minus 0.15.
Yep.
Equals 2.2583.
Equal, and that thing's square root is 2
Yeah.
point what?
2.2583.
2583. Okay, so I'm gonna round that to 2.25. That's okay. No, 2.26.
2.6.
So I asked, is 10 with defects unusual? Well, what was our range for usual? Camilla's flashing me gang signs. 2 standard deviations. So our mean of 6 plus or minus 2 times our 2.26. That's 6 plus or minus what, 4.52. So the top end of that range is 10.52. I don't know why my thing changed all of a sudden. It's irritating though. And the bottom of that range is what, 1.48. So is it unusual to get 10? No, 10's in this range for usual. It'd be unusual to get, I'm 11. Is it unusual to get a perfect batch of 40? Perfect batch of 40 would mean 0 with defects. Zero's outside of that range. So we get some nice little tools for mean and standard deviation, which means we can do all of our average, all of our expected value, all of that standard deviation conversations that we've been having very nicely with much smaller formulas, thankfully.
So Matt?
Yeah.
In the homework,
Mhm.
They ask if a certain number is unusual or usual, but all you've found is the probability. You haven't found the mean or standard deviation. Do you have to go in and do that?
Yep.
To get a yes or no answer on those?
Yep.
Ew.
Well, you should anyway.
Yeah. Is there a way to kind of look at the probability and
Well, yes, 2 standard deviations, remember, is our middle 95%, right?
Right.
So if the probability is outside of that middle 95%, it's got to be outside of 2 standard deviations. So if the probability is anything less than like 2.5, because that's the 5% outside, the 2.5 on the above, 2.5 below. So if it's less than the 2.5%, it's has to be unusual.
So would you can you look at one of the questions on 6.2?
Yeah, which one?
It's number 7. And the probability part seemed easy to me, but the telling whether that was unusual or not. So take a look at it, because I got a probability at the bottom of 0.0587, which they said was correct. And then they said that's not unusual. And I thought that seemed unusual.
So see, you have 12 students in your program.
Yeah.
Exactly 9 of them graduate. And you got what?
A year, you probably have different numbers than me.
Yeah, but what did yours say for your
Okay.
probability was, you said 0.05?
Yeah, the last part of 7, I got 0.0587.
So
And
that's bigger than
that was
5%.
correct. Huh?
So that's bigger than 5%.
Oh. So 2.5%.
Well, really, we're looking for that 95. That 2 standard deviations is that 95. So your threshold is going to be a little bit, I think your book even says it wants that 5%.
Oh, so if it's 5% or
If it's less than 5%,
less
it's
than
unusual.
5%,
If it's
unusual.
5% or more, it's not unusual.
Oh, great. Thank you.
Sure.
I figured there'd be an easier way than having to calculate the whole
Yeah.
mean standard deviation, okay.
But the key is that 2 standard deviations is 95%.
Okay,
So if it's outside of that 95%,
yeah,
it's unusual.
that makes sense. Thanks.
Sure. Is it just me, or did it go fast today? We did a lot today, though, didn't we? These types of problems, really, it's all the same tool we talked about yesterday, but the little details in what the question's asking and how we have to use those tools is what's important here. So it does take a fair amount of practice, so go through those, pay a lot of attention to the ones that are at least more than, at most, those little details about where exactly that endpoint needs to be. And getting back to Jesse's point, you can just go, okay, try it with 6, didn't work, try it with 7, didn't work, try it with 5, hey, it worked, I'm going to go on. If you are doing that, you're going to get in a lot of trouble. Fair. If you're trying, 7 didn't work. Okay, well, why is it not 7? If 6 worked, why is it 6 instead of 7? Have it give you another one. If it said, yes, you're right. Okay, give me another one. Let me see if I can, see it this time of why that difference is there. Because usually if you kind of throw the numbers at it, you'll get a right answer fairly quickly just because you're dealing with the right pieces. But we've got to have that, why is this what it's supposed to be? Fair? So go play with these. Let me know if you need anything.
So Matt, I have another question before you go, but it's
Okay.
more, it's back on the test. I have a question on the last test.
Oh, okay. Oh, and I got your email. I saw your messages about the labs, but not anything about the test or anything else.
Yeah, no, somehow I think what happened, I want to know if you go out of the test into Excel and you close out the test, if you come back in, will it give you a different question?
No, I think.
Because I wanted you to look, I sent you the work on problem number 5. I thought I got 100% on that test, except for the stupid mean thing that was just arithmetic error. But that whole number 5, you can see my work is a whole different set of data than what goes to that question. And I
Yeah.
can't find it anywhere in the test, and I don't know where I copied it from. I was trying to figure out how in the heck could I have gotten, and I wanted to know if the answers I gave were correct for the data I had.
Right.
You know what I mean? Just
Yeah.
for my own, because I don't care about the grade. But that's why I sent you the technology part, you know, the part that I'd done on Excel.
Right.
And I thought I got that whole Excel thing down, but I rearranged the numbers. You can see they're not the numbers that go with the problem.
Well, let me check.
It's
So-
so
Other than that, if you guys want to wander off, we're fine. Oh, I did want to mention, if you're looking at setting up your or registering for math classes in the what do you call it? In the fall, some of the scheduling stuff with the new system is a little bit off or weird. If you're trying to sign up for math classes and you're unsure about it at all, send me a note, send me a message. I've got a copy of what the schedule is supposed to be, all the sequencing. So let me know, and I can give you more information, or tell me what you're trying to sign up for. I can let you know more if you're having problems with that. If you're not and it's working, great. If it's giving you any problems, let me know, and we'll try to get you as much good information as we can. Okay? Okay. But other than that, have a wonderful day. Probability worksheet. No. Where did you send the tech? Oh, was that on My Open Math or on, or? An email, Kim. You're muted.
I know you didn't see my test at first, so I probably sent it the wrong way, but then you were able to pull it up.
Well, yeah, no, I mean, where did you send in the,
Question? Oh, the work.
Your
It's
data.
under the work. On problem 5, it says work, and I made a copy. I tried to make a copy of the Excel.
oh,
But
you put it there. Okay.
Yeah,
Gotcha.
that's what I'm talking about. I tell you, technology. I'm trying it.
Why did you just curious, why did you close out the test to open up Excel? You can have them
Because
both
I'm
open.
stupid.
Well, okay, it's not
I mean, I could have
not
just.
the answer I was
started-
looking for, but okay.
No, I should have just minimized it and then gone back the test. And I'm not sure that's what I did, but I cannot for the life of me figure out where I got that data.
Yeah,
You see, it doesn't match at all.
no, not at all. Well, some of it,
I mean, the
338.
questions, my answers are the answers to those questions, to that set of data. But that doesn't match. That wasn't what the question was asking.
no.
And I don't know how I copied that data wrong into Excel.
Some of the data is the same. 3, 4, 3, 3, those are the same. 285. 285 is there. 218. It's the same data, Kim. You put it in order.
Yeah. But
249, 249, 212. Well, I'll tell you what happened.
what?
It's the same data,
Oh,
except it's just your data is in order,
Yeah.
except for 2 of them.
don't match.
And it's because it has a 2.3,
Uh-huh.
and in your Excel document,
Yeah.
the 2.3 turned into a 0.3 and a 2.
Oh, crap.
Yep.
See, that's what I did. I knew I'd copied the data. I thought, where did I get that data? How did I get the data wrong?
Well, all the rest of them are the right data. They're just in a weird order because you ordered it. But
Yeah,
the 0.3 and the 2 are the ones that look really weird
Yeah.
because it's supposed to be 2.3.
Okay. So just somehow when I copied the data and I put it in Excel, I miscopied it.
Or it happened when you were clicking on it for the sort. You know, you were moving stuff around, or
right.
something happened when you were
When I
transferring it over.
I sorted it, and then I looked at my notes from the test, and I did all those questions off of the data that I have on that, in that list,
Yep.
which was not the right data.
Nope.
But I was just curious. Obviously, everything except for the quartile, the interquartile, you know, the quartiles,
Mhm.
I didn't use Excel to do that. I did that by hand and lower. And
Right.
I was curious if I did it right, because I went back and I did see where I'd done the work on that wrong set of data. Yeah. And I just wanted to know if, like, can you look at that and see if I got the right quartile 1 and quartile 3?
Oh, given your data?
Yeah.
Yeah.
Because you can see I got the answers
15,
from that data.
8. Yeah. Hold on. 1, 2, 3, 4, 5, 6, 7. 2.02, 3.4. Yeah.
Okay. Yeah. Okay. So I'm not worried about it. I felt really confident that I knew what to do there. And I thought I got all of those right. And then I missed them all. I don't even know how I got one right. You know?
Yeah, one of the upper quartile wasn't affected by it because it was the small range data.
Oh. So that's why I was. Okay, I don't feel so bad then. Because all I care is that I'm telling people that when I'm trying to work with other people, that I'm telling them the right information. But, you know, that, like, missing that mean question, that's just arithmetic error, which is, I'm the worst. I tell my students, I said, you know, you got to check my arithmetic.
Oh yeah. Well, particularly when you're, you know, instructing, because your brain is thinking 4 or 5 different things.
Right. Yeah.
Yeah.
And I have enough time to, like, double check my answers. I'm just too lazy. I know.
Well, and that's not your goal, really. Is not to,
my goal is to make sure I did the Excel, and I feel much better this term about getting the Excel stuff. I'm going to try to do that other lab because I didn't do much on the Excel last time.
Yeah.
So, okay. I appreciate it. And I still don't have grades for my labs.
Well, I know you have grades for that one lab. The other labs.
If I go into my grade book, it says NA for both of them.
I'm looking at it right. It's right in front of me.
Okay.
Lab 1, 30.
No. But you never got my lab 2?
I have it. I just haven't put it in yet.
Oh, okay. But no.
Yours is separate.
I don't know if I can show you. It's not showing up on mine, which I don't care. I just am trying to make sure I do it right. You know what I mean? I don't care about the points. I don't care about the grade, really. I care about making sure.
Well, you can share your screen if you want.
Okay, let me see if I can do that. Let's see. Now you're asking for a really hard.
Camilla, did you have a question?
Well, I just wanted to know if